Welcome back, NC Kings, NC Queens, NC Weeds. That's what we used to call the 7th and 8th graders back when I was here. I think they're the Tritons now, but hard to give up old habits. Okay, moving on. Coordinate Geometry Math 2, it's today lesson 10. Our goal today is to solve problems with this idea. And that idea is that the slopes of parallel lines are equal. We knew that back when we did constructions. Today we're just going to put it on the grid, prove it. All right, so you're asking me, how do you prove parallel lines are equal? Well, you start by drawing a parallel line. Actually, you start by drawing any line. Let's draw a line here and just say there's a line, and it looks about like that. And if I want to draw a parallel line to that, I have to translate. So we're going to translate here. This point right here is going to translate. I'm going to go 4 over and 1 up. So 1, 2, 3, 4, 1, 1, 2, 3, 4, 1. I can translate this point right here. 1, 2, 3, 4, 1. So I make it a translation, and then I'm redrawing my line. This isn't perfectly neat, but it gives you the idea. Oops, that's not the neatest line in the world. Let's do that a little more high quality there. My stylus doesn't want to do it. So either way, this is what we're doing. We're drawing two lines on the grid, and we're checking their slopes. Well, this slope goes to the left, 1. So that's a change in y, no, change in x. X on the bottom, remember? That's plus 1. And then it goes up 1, 2, 3, 4. So that's my change in y. Y? Why not? Plus 4. So that means that thing's got a slope of 4. And you know, all those points get moved over. You still got a slope of 4. Because it's just all you're doing is moving all these coordinates. There's a directed line segment there, but they're all going across the same places. So you got a parallel line. So translations create parallel lines. Now, what do parallel lines do without a grid? This is where we come into play with Priya here. And Priya has a little going on here with two parallel lines. They're not horizontal, they're not vertical. Therefore, they must pass through the x-axis and y-axis. That's her idea. Okay, great. That's not a big mystery. There's your x-intercepts, there's your y-intercepts. Okay, not sure why that matters, but in this case, by doing that, we get two right triangles. That's the whole idea here. We got two rights. And when you get two right triangles, guess what? You have a congruent angle there, which is right triangle. And then this one right here, those are also congruent because they are alternate interiors. So if you think about that for a moment, they're alternate interiors, or these two over here are vertical. Those are vertical, and then those are corresponding. Either way, you've got a right angle and another angle. And once you've got angle on a right triangle only, they're congruent. It's because the right angle, they're fixed. They're kind of rigid, if you will. So when they're fixed, those are congruent angles, but the triangles themselves are similar. Okay, so here's the idea. The angles are congruent, but the triangles are similar. That's kind of important to the difference there. And when similar triangles mean they have proportional sides. That goes back to trig a little bit. Proportional sides mean that their ratios are proportional. Okay, there's a scale factor going on there. So that means the slopes are going to be equal there. So we could check those changes in y's and changes in x's. And that's Priya. Just take a look at that proof here. Let's see. Knowing that, can we do something with this knowledge? Write the equation of line parallel here that passes through this point. Well, here's what we're going to go for. We're going to go for this. Y minus k equals m times x minus h. Why are we using that formula? Because that is the formula for the equation of a line in point-slope form. So in other words, this makes this kind of nice. It goes through that point, negative 4, 1, so we can use that. That is on h, and that is on k, right here. So h is negative 4, k is negative 1. So here we go. We're just going to rewrite it. Y minus 1 equals. It says that the slopes are the same, so hold on the slope for a minute. Let's just get the x here. That's x minus negative 4, so we're just going to say x plus 4. And it gave me the slope over here of 2. So that means the slope is still 2. I don't know how to make that any easier because that's it on this case. Okay, so write an equation of a parallel line. We're not going to go right now prove the parallelogram yet. We're just looking about writing things that are parallel. Can we prove it's a parallelogram? Yeah, we can draw the two things, but they didn't give us a grid, so I'm gonna lay off that problem for a moment. I'm at 5 minutes here, so I'm gonna keep this to 10. So really just writing that equation of a parallel line. Now if it's on a grid and you have two lines, you can calculate the slope and you can prove their parallelogram that way. But basically you're graphing these lines and they are parallel. Now if you graph two more lines and they're also parallel, you will end up with two sets of opposite parallel lines. It'll be a parallelogram no matter what. That's what we need. All right. So bottom line, well, not bottom line yet. Summary first. This is the idea is that by drawing the parallel lines and connecting them to the axes, you've got this situation going on here. Yeah. Real Housewives of New Jersey or whatever that Jersey Shore, yeah. The situation, Mike. We've got a Mike going on here where we've got this triangle similar to this triangle. They're similar triangles. Therefore, they have proportionate side lengths. So in other words, their changes in y and their changes in x here are going to be the same ratio. And a ratio is a slope. Rise over run. All right? That ratio, the change in y divided by the change in x. Okay, and let's take a look at the numbers real quick before we move on. Let's take a look at these numbers right here. Let's see. These lines are parallel, and it looks like they've got a slope of negative. Rise and run. This one is 1/2. The little guy is 1/2, and the big guy is 3/6. Guess what? That's the same thing. 3/6, 1/2. All good. Okay, let's take a little practice here. Select all the equations that are parallel. Here's where it gets a little interesting. You may have to rearrange something here. So, but basically, well, we want to solve this thing for y. So here's what we're going to do. We're going to subtract 2x from both sides. So we're going to get 5y equals minus 2x plus 8. And then we're going to divide everything by 5. So we're going to get y equals minus 2/5 x plus whatever 8/5 is. I really don't care. I'm going to leave it 8/5. Parallel, all we're really looking at is the slope. All that matters is the slope. So do we have a minus 2/5 slope over here? Let's look for it. Yes, we do, right there. B, winner, winner, chicken dinner. A, no dice. It's positive, so that's actually something different. And then over here on C, we've got 5/2. That ain't it. D, we've got a point slope formula, but it doesn't really matter because we're just looking at the slope. We don't care about the points, just the slope. Parallel, that's all we're trying to prove. Parallel, that's all we're looking for. Minus 2/5, yes. And this last one, yeah, that one we can't really tell, so we got to convert it. And I'm going to convert it real quick. Subtract 10x from both sides. You get 5y equals minus 10x plus 40. And then you divide by 5. Well, right there, when I divide that 10 by 5, that's not 2/5, that's 5/2. So, E is out. All right? Rewind if you need to check that again. We're trying to keep this, like I said, I got 1 minute and 13 seconds. So, write equation of a line that passes through that point and is parallel to this line with the x-intercept and the y-intercept. Ooh, well, yeah, I'm not going to be able to keep this under 10 minutes now. So here's what I'm going to do. I'm going to draw this thing real quick. I'm going to say, what's an x-intercept here? What's a y-intercept? Here they are. X-intercept, 3, 0, right there. 3, 0. Y-intercept, 0, 1, right there. 1. Okay, right there I can get my slope, all right, from that line. I can see the coordinates, so I can actually kind of draw a little wavy line here. That line has a slope of negative 1/3. And that's where we want to be at. No slope formula. It goes down by 1 and then over by 3. So it goes kind of negative 1, positive 3. All right, now that I got that, I got my slope. So let's see. That's my intercepts. There's my point. Negative 1, 2. I'm just going to write the equation. Y minus 2 equals negative 1/3 x plus 1. All right, so that's where I'm getting my point. I'm using it in here for x and y. There's my h and k. That's the problem. All right, that's right there. We got it. All right, let's do a couple more here for practice. So this video is going to go a little long, but not too much. Let's back it on up here. Let's take number 4. Number 4. You'll notice what I'm doing. I'm drawing a picture. Draw the picture. It's good. Good for you. Drawing pictures is healthy. So number 4 now. Let's take a look. We got an equation with a line. There's the slope. Gave it to us. It goes through this point. Oh, my gosh. Okay, let's just go right at it. That's my h. That's my k. Know your equations, folks. Know your format. So that's going to be y minus 5 equals slope, 2/3, x. Oops, that doesn't look really like a parenthesis. X minus, nope, x plus, because it's x minus 2. That's that one. Okay, Priya and Han, our last problem here before we walk out the door. Got equation of a line. So Priya, let's see, here's the first one. The first one is actually y minus 2 equals 1/3 x minus 1. Because that's that line right here. There's your h and k, there's your slope. Priya says, well, there's my equation. Y minus 2 equals 1/3 x minus 1. Ding, ding, once again. Winner, winner, chicken dinner. So Priya wrote the same equation we just did. Got it. Check. Done. But then Han says, ho, ho, ho. No go. He says, I got 3y minus x equals 5. How do we reconcile those? Well, what you really want to do, here's the conversion factor. You want to convert both of them to y equals mx plus b. That's your easiest way. So do this. I'm going to go to the right. 3y equals x plus 5. In other words, I added x to both sides. And then I'm going to go y equals 1/3 x plus 5/3. And that's because I'm dividing off that 3 right there. Okay, and let's take over the other side and go, okay, well, over on the left side, if we do that same process, and this is that idea of process, first of all, add 2 to both sides. Y equals 1/3 x minus 1 plus 2. Then distribute your 1/3. So y equals 1/3 x, and that looks just like Han's equation. And then here you got minus 1/3 plus 2. Well, guess what? 2 minus 1/3, 2 is 6/3 minus 1/3. That right there is the same as 5/3. So yes, they're both right. All right, on that note, they're both right. We'll just take that and say the bottom line here before we get out. In 5 seconds, you need to be able to determine the slope of a line quickly from looking at it on the grid or just using a quick change in y, change in x. That's all that is. Understand that to be parallel, 2 lines need to have equal slopes. Done. And here's the big one. You need to be able to algebraically manipulate a linear equation to go from standard form, slope-intercept form, and point-slope form. So you got to do some algebra there, folks. That's going to be kind of needed along the way. All right, that's 13 minutes and 20 seconds. I'm a little over the end, so I'm going to stop right there. And that is lesson 10, unit 6. Thank you very much. Appreciate it. Be back tomorrow.